Hello everyone, let's jump straight into it then. So building on from the fluency that we did yesterday then. So 8 plus something equals 10. What is our missing addend in our number bond to 10? Well done if you said 2. Fantastic, hopefully we know that super fast right now. So today what we're going to do is we're going to look at how we can use our number facts to 10 to now help us with a different number fact. So what is the same and what is different between our two addition equations? What's the same and what's different? Excellent. So they both start with 8, but this time I'm not trying to make 10, I want to make 20. So let's think about what we know about the number 10. Well, the number 10 is made up of 1 10, and the number 20 is made up of 2 10s, but they are both made up of 10s. 1 10 and 2 10s for 20. So let's have a look then at this represented with our numicon. So 8 is what I'm starting with. What do I need to add to my 8 to make my whole 10? That's right, I need to add 2. However, you might notice that over here, if I have 8, that's still going to be 2 that I need to complete this whole 10. But when I make 20, I've got a whole extra 10 here that I didn't need to make when I was just making 10. So what that means is that I need to add, to be able to make 2 whole 10s, I need to add my 2 1s to complete, there we go, to complete my whole 10. But then I've got a whole extra 10 here that I need to add. So altogether, I would need to add 1 10 and 2 1s, which would be 12. So what you can see from my equation here is that my 2 1s and my 8 1s, they add together to make a whole 10. But I don't just want to make 1 whole 10, I want to make 2 whole 10s because 20 is the same as 2 whole 10s. So that means my other 10 here also must be added, and that's represented by the 1 10 in my number 12. Okay, so I've changed our equation this time. So now we're looking at 4 add something equals 10. So what do I need to add to 4 to make 10? Did you say 6? Well done if you did. So having a look then at the differences then, I know that this is trying to make 1 10, but this equation over here is trying to make 2 10s. So let's have a look at that. This is our 1 10 that we're trying to make, and this is our 2 10s. So I'm starting with 4, so I'm going to put that on here. What do I need to add to complete my 10? That's right, I need to add 6 to complete my 10. And you can see that 4 and 6 together is the same as 10. But over here, I want to make 2 10s. So I start with 4 because I'm starting with 4 here. So not only do I have to complete this 1 10, I've got a whole other 10 here because I'm trying to make 2 10s. So I know that to complete this 10, I need how many more? You can use this to help you. Lovely. I need 6 more 1s to complete this 10. So I say that I need 4, add 6 more 1s because that will give me 1 whole 10 here. But I'm not trying to make 1 whole 10, I'm trying to make 2 whole 10s. So I've got a whole other 10 here that I need to add to make 20. And I write that here, my 110, so that I can show that I've got 110 and 6 ones that I need to add. So what you can see here is 4 plus 6 equals 10, but 4 plus 16 equals 20. And that's because I've got this whole extra 10 here. That now means that my 2 ones, here we go, my 2 ones add together to give me this 10 here, and this 110 in front of my 6 ones shows me that I've got another 10 here, and when I add those together, I get my 2 10s, which are 20. So when we are starting with a single digit number and I'm trying to make 20, you might notice that the second addend must also have our additional 10 here. So if I know that 5 plus 5 equals 10, well then 5 plus something to equal 20, well I know that 5 plus 5 would give me 110, but I need to make 20, which is 2 10s, so my extra 10 goes here. Can you have a go at completing all of these missing numbers using what we've just learned, and then we'll go through the answers. Lovely, well done for having a go. Hopefully you are ready to go through the answers now. So if I know that 6 plus 4 make 10, well I know that 6 plus 4 will make 110, but 20 is made up of 2 10s, which is an extra 10, which goes here. So it's 6 plus 14 equals 20. 7 plus 3 equals 10. So if I know that 7 plus 3 equals 110, I know that if I have a number that has an extra 10 in it, that would now make 2 10s. So 8 plus 2 equals 10. That means that 8 plus 12 equals 20. 9 plus 1 equals 10. So that means 9 plus 11 equals 20. And 4 plus 6 equals 10. So that means that 4 plus 16 equals 20. Well done if you got those right. So very quickly before we start to jump straight back into our shape unit, building on from what we did yesterday and the day before that, we can use this one simple number fact, 8 plus 2 equals 10, to not only show us our inverse operations, but it can also help to show us our number facts to 100, as well as the inverse operations. And it can also help us with our number bonds to 20 and its inverse operations. So let's keep working on this. And what we're going to do is we're going to see just how many number facts I can remember based off this one. Okay, so we're going to do something a little bit unusual today, and that is start our maths lesson off with a video.
Hi everyone! Today we're going to learn about symmetry. Symmetry is a concept that is commonly found in math, especially geometry, but it is also often discussed in art and design. An object that has symmetry can be divided into identical pieces. When an object has symmetry, we say that it is symmetrical. When an object does not have symmetry, we say that it is asymmetrical. There are many different types of geometric symmetry, but today we are only going to talk about the simplest form, reflectional symmetry. An object or image that has reflectional symmetry is like a mirror image. If you were to draw an imaginary line down the center of a symmetrical object and fold it in half along that line, the shapes would match up. This imaginary line is called a line of symmetry. Some symmetrical objects only have one line of symmetry, while others have more. For example, this triangle only has one line of symmetry, straight down the middle, because if you try to divide it any other way, the pieces don't match up. This triangle, on the other hand, has 3 lines of symmetry. You could fold it here, here, or here, and each time the halves would be the same. A square has 4 lines of symmetry. You could divide it in half from left to right, top to bottom, or from corner to corner either way. Symmetry is often found in nature. One favorite example of this is a butterfly. When a butterfly folds its wings, it is easy to see that they are the same shape. Now that you know what symmetry means, see if you can find symmetrical objects near you. You may be surprised by how many things are symmetrical.
So let's have a look at using a Freya model to really try and understand what it means by symmetry and a line of symmetry. So a line of symmetry is a line that splits a shape exactly in half. Now we've looked at halves just this week on Monday, and we noticed that 2 halves make 1 whole. So they both must be equal. They both must be identical halves. That means the same. So a line of symmetry is a line that splits a shape exactly in half, so that both of the sides, both of the halves, they match each other exactly. Okay, so let me show you what I mean by that. I've got a sheet of paper here, and my sheet is, you might be able to tell me what shape it is because it's got 2 long sides and it's got 2 short sides. It is a rectangle. Well done. So this is my rectangle here. And if I fold my sheet of paper so that both of the sides match up exactly, there you go, you can see that both sides touch each other perfectly. They are exactly equal and in half. So I would say that that line that goes down that middle, which is, and I'll draw that on for you, which is here, is a line of symmetry, because when I fold it on that line, both of those halves are equal. They match each other exactly. Now, if I try to fold my rectangle corner to corner like this, you might notice that they do not match each other perfectly, because you can see down here, if you have a look, I've got some sticky out bits on that side. They do not match each other perfectly, and on this side as well, I've got some other sticky out bits. So that is not a line of symmetry, because my 2 halves are not identical. They don't match each other perfectly. So that's what we mean when we say a line of symmetry. A line of symmetry can go in any direction. They can go vertically, they can go horizontally, and they can go diagonally, as long as each half within that shape, when you fold it over or when you look at it in a mirror, they look exactly the same. Each opposite vertex, now what that means is each opposite corner, remember we did this word yesterday, is equal distance from the line of symmetry. So let's have a look at our rectangle's line of symmetry again. This vertex and this vertex are the same distance away from our line. If I go out like this, they are the same distance away. But when I fold this one, so let's say that's my line of symmetry, well then this vertex and this vertex are very, very different distances away from that folded line, aren't they? So that's why that's not a line of symmetry. the opposite corners from each other in the mirror line have to be the same distance from that line of symmetry. A shape must look the same on each side of the line of symmetry. They must look exactly the same. And some shapes, like the lady said in the video, have many, many lines of symmetry, but some shapes don't have any at all. And some might just have one. So what we're going to do now is we're going to go through some shapes that I've got here, and we're going to decide whether that is an example of a line of symmetry or a non-example. Let's have a look at this one then. So this is a 1, 2, 3, 4, 5, 6-sided shape. Can you remember what a 6-sided shape is called? Well done if you said that it's a hexagon. Fantastic. So I can see that this shape, this hexagon, is a regular hexagon. That means whichever way I turn it, it will look the same. There you go. It's my regular hexagon. So there's my hexagon, and I've got my line of symmetry. There we go, I've got my line of symmetry going down the middle. So let's take this vertex, for example. Is it equal distance from its opposite vertex? Yes, it is. Is it split exactly in half? Is this side the same as this side? Yes, it is. So it's an example. What about this one? This is a 1, 2, 3, 4-sided shape, but it is not a rectangle or a square. So we would say that this is a, well done if you said quadrilateral. So I've got a line here, and I need to work out whether this side of the shape is the same as this side of the shape. If I folded that shape on that line, would it match up exactly? No, it wouldn't. And I can tell that because this vertices here and this vertices here are opposite each other, but they are different distances away. And you can see here, this is a very short distance and this is a very long distance away from our line. So that is not an example of a line of symmetry. What about this shape here? There we go. I've got a 7-sided shape. It is not a regular 7-sided shape, and we would call this a heptagon. Well done. So our arrow is a heptagon because it has 7 sides. Now, if I fold this shape in half along this line, would those halves match up? No, they wouldn't. It is a non-example, and you can see that here. Because if you look at this vertices here, there isn't one here in the same distance away from the line. It's just not there. They're not the same at all. Let's have a look at this one. So I've got my triangle here. If I folded my triangle like this along that line, would they match up exactly? Do they look the same, these sides? No, so that's not a line of symmetry. Well done. What about this one here though? If I folded that triangle along that line, would my halves match up? Yes, they would. That is a line of symmetry. Fantastic, well done. I know that was really tricky. So what we're going to do is we're going to start off by reviewing our success criteria and then ticking true or false to show whether it's a line of symmetry or not. So a line of symmetry splits a shape exactly in half. Well done. Both halves of the shape must be the same. If a shape has one or more lines of symmetry, then we would call that shape symmetrical. So here we go. These shapes are symmetrical. If the two parts are not equal, then the shape is not symmetrical. So these shapes here are not symmetrical. Oh, whoopsie daisy. Okay, so going back to our shape then. Well, if I was to fold my rectangle in half along that line, would my two halves be the same? Would they match? Well, they would. I could see that this is 1, 2, 3 squares away, and this is 1, 2, 3 squares away. I could tell that if I folded them over, they would be equal. So this is true. Well done if you said that. Have a go at this one. Do you think that if I folded this shape over, it would be equally matched? Okay, so let's have a look. So if I choose this corner here, this vertex, and I go down, I can see that that's 2 squares away from our line of symmetry. If I go down 2 again, there's nothing there. So they don't match up. So it is not symmetrical. This is false. And I know this is false because my 2 vertices would not match up. So now we've got a shape here for us to draw a line of symmetry on. So what we need to do is we need to find somewhere where the shape can be split exactly in half. Remember, a line of symmetry can go in any direction. It can go vertically, it can go horizontally, it can go diagonally as well. So if I were to split my shape here, would these 2 halves look the same? Not at all. So we need to have a think about where it would be best split. And it is down the middle here. And we can see that from our vertices. If we choose a vertices or a vertex, we would go 1, 2, 3 to the middle, 1, 2, 3. Perfect, it matches up. Let's try another one. This one here, 1, 1. Perfect, it matches up. They are equal distance from their opposite vertices. What about this one? So this shape has got 4 equal sides. What would we call this shape? Lovely, this shape is a square. So let's have a look at going down the middle. So is this the middle of my shape? So I've drawn it on the lines of the squared paper. Is that the middle of my shape? No, that's not the middle, and I can tell that because if I choose a vertices or a vertex, then I will go 1, 2 to the middle, 1, 2. Oh, well, this one has an extra one, that one's 3, so that is not the middle of my shape. But perhaps if I move it over slightly, I have to draw a new one, sorry. If I move it over slightly to see, all in all, I've got 1, 2, 3, 4, 5 squares along the top. So I would need to go halfway between my 2 lines there. So you don't always have to use the lines on the square background here, okay? So here I can see that this vertex is 1, 2.5, and this vertex is opposite 1, 2.5. So that is now in the middle. But it is a square, it is a regular shape. So that means that if I can fold it that way, then I must also be able to fold it this way because all of my sides are the same. But squares can also be folded diagonally and they would match up. And if they can be folded diagonally this way, then they can also be folded diagonally this way as well. So a square actually has 4 lines of symmetry. Okay, this time we don't have any squares to help us. We just need to find a line of symmetry. Maybe you can pause the video and draw on the screen with your finger where you think that line's going to go. Okay, so super. Remember, a line of symmetry can go in any direction. We can go vertically, but for this particular shape, that would not work because this side has a point and this side has more of a rectangular shape. So that wouldn't be right. Maybe we could try horizontally. Now, if I folded my shape, would those two halves match up exactly? Well, yes, I can see that. Now here I don't have those squares to help me, but I can see that those opposite points are very roughly the same distance away from each other. There you go, you can see that there. And this point has been split in half via that line of symmetry. Super, so let's have a look at this shape then. So this star shape. So I could try going this way. Does that look the same? Yes, super. But what's really interesting about our star is that if I were to rotate it, then it looks the same again. So maybe I could say that at every point I could show my line of symmetry this way, or from this point, or from this point down the middle, or from this point down the middle. So this star shape actually has 5 lines of symmetry. Okay, so now we've got some reasoning to do. Are these correct? So first of all, let's have a look at this. We'll call this one A. Is A line of symmetry? So the line of symmetry in the rectangle, because it's a rectangle. Now remember, we just did this. I showed you my rectangle and I tried to fold it from the corners. There you go. Did they match up? No, they don't match up. You can see here, I've got my sticky out bits. Here it's sticking out as well. So the line of symmetry in the rectangle is not correct because if I folded my shape along that line, the two halves would not match up. They would not be exactly the same. What about this shape here? What shape is this? B. This is a triangle. Well done. It's got 1, 2, 3 sides. So the line of symmetry in the triangle, is it correct or not correct? Well, remember, we can have a look at our vertices. Let's go opposite. Would we say that they are equally spaced here from that line of symmetry? I would. So I would say it is correct because the opposite vertices are the same distance away from the line of symmetry. So that means if I were to fold them over, they would match exactly. And what about this? C. What shape is C? That's right, C is a square. 4 sides, all the same length. So is this line in a square a line of symmetry? Well, what's special about a square is that all the sides are the same length. Unlike a rectangle where we've got 2 long and 2 short sides, all of these are the same length. So if I were to fold it on this line, then they would match exactly. So the line of symmetry in the square is correct because if I folded the shape on that line, the halves would match exactly. Okay, so what we need to do now is have a go at these, putting these shapes into their correct place on the table. So if they have at least one line of symmetry, then we say that they are symmetrical. If they do not have any lines of symmetry at all, they are not symmetrical. So why don't you pause the video and have a go at organising them, and then we'll go through it together. Lovely, well done for having a go at that year 2. Let's do it together then. So let's do the shape. Ooh. Let's do this shape here. So if I tried to fold it this way, would it be equal? No, because I can see that this bit goes up and this bit goes down. So those opposites would not match up. What about if I try to do it this way? Well, no, because this side has a straight line and this side has a curved line. And definitely not the same if I do it diagonally, because once again, this side has a curved line and this only has straight lines. So that means that this shape has no lines of symmetry, so it is not symmetrical. What about this shape then? Well, I think this one is very easy to tell that whichever way you split it, it will not have any lines of symmetry at all. Very, very irregular shape. What about E then? Let's have a look at E. Well, we know that this is a regular hexagon. So if I were to go down the middle, that would have a line of symmetry going vertically, horizontally, and diagonally as well. So that shape is symmetrical. What about our regular pentagon? Well, our regular pentagon can be split vertically. So that definitely has at least one line of symmetry. What about our quadrilateral here? Well, it does have some long sides and some short sides. So if I split it this way, that would not be symmetrical because these points would not match up. However, if I try to split it vertically like this, then I can see that this vertex and this vertex, they are the same distance away from that mirror line. So it does have one line of symmetry, so it is a symmetrical shape. What about A then? What about A? Well, if I cut it in half vertically, will those sides match up? Do they look the same? Yes, they do, so this shape is symmetrical. What about this funny shape here? If I try to do it vertically, would that work? No, they're not equal. This has got a whole extra side on this side. What about if I rotated it in some way? No, I don't think this one has any lines of symmetry, so this shape is not symmetrical. What about our lightning bolt? Very funny little shape. There we go. So if I do it this way, do I have a line of symmetry? No. What about if I try to do it this way? Do those sides look the same? No. Well, from this side it goes up and from this side it goes down. If they were the same, they would both go up from this way. So this is not symmetrical. And then last but not least, our other quadrilateral. So would we say that those two sides are equal? They're identical? No, because again, this one goes up and this one goes down. If they were identical, this one would also be going up. What about if I rotated it maybe? Are they the same? No, again, you can see that because if I look at my opposite vertices, they are not matching up. So again, this one is not symmetrical. So let's go through the worksheets from today then. You can either pause the video here and have a go at maybe drawing the shapes, but I think the best way for you to do it today would be to download the sheet from the Byron Wood website. What I'll do is I will pause the video, open up that sheet, and I will show you what I've done for you to be able to answer the questions at home on this Word document. Okay, so hopefully you can see my screen now. Now this is the worksheet that is available to download on the Byron Wood School website in the home learning section for year 2. So that circle sheet has those pictures on for you to answer true or false. Now, if you think it's true, you click in the true and you can just type an X. If you think it's false, you can click in the false and you can type an X. I've just noticed that unfortunately my false word has the E missing because it's too big for the space So I am sorry that it's come across, I haven't spelt it wrong. So there you go, just click in the box and mark whichever you think it is, true or false. Right, for that semicircle sheet then, that semicircle sheet is asking you to draw your own line of symmetry. Now you will see that I have created a red line for you. Now if you click on that red line, you can drag that red line to wherever you think that line of symmetry should be, and you can make it long like this by stretching those blue circles, and you can drag it horizontally if you want to, like this, by just keeping adjusting it, or you can even drag it diagonal for you to draw those lines of symmetry on, okay? When you've managed to do all this, you just save it, you go to File, and you press File, Save As, and then you can save it as a document and send it back to your class teachers. Same again for the triangle sheet. That red line is there for you to click on and drag to wherever it is that you would like to draw your line of symmetry, vertically, horizontally, or diagonally, depending on the lines of symmetry that you can see. Please make sure that you've double checked that they go across the correct vertices that you want them to, and save it and send it to your class teachers. And the square sheet has got some draggable shapes on it. So square, we know that the square has got 4 lines of symmetry, so I know that it is a symmetrical shape, so I drag the square into the symmetrical section. I remember the lightning bolt had no lines of symmetry, so I drag that into this non-symmetrical part of my table. And that is it. Of course, if you want to just go through the flip chart and pause the video for each one, then you're welcome to do that. It will just be a lot more difficult for you. Okay, if you're having trouble managing to do the work at home, please do get in touch with your class teacher and we will do everything that we can to help you out at home. Well done everybody once again. We know that it isn't easy, and it's especially difficult doing lessons like this at home, but you are doing an amazing job. Remember from the story yesterday, as long as you try your best, that is enough. So well done everyone. We'll see you for another maths lesson soon. Bye.